Hey guys, so today I want to teach y'all about binary ionic compounds and basically how to write the formulas and how to name them. So binary ionic compounds, binary honestly that sounds complicated, but that word just means that you have two ions that make up the compound, okay? And this is your practice sheet. So as I teach this, I'm going to be doing a couple of these examples with y'all. So you have ions, okay? There's going to have to be a positive ion reacting with a negative ion because opposite charges attract. So the positive one is your metal, okay? The negative one is your, I don't know what I was about to write, but it is your nonmetal, okay? And when you're looking at your names, they always do the metal first and then the nonmetal. By the way, on your periodic table, metals are on the left side, nonmetals are on the right. In the names, the metals on the left side and the nonmetals on the right. So it goes in the same order, okay? It's understood that you're always going to have a positive with a negative. So when you see the names written, it actually comes from following a few simple steps. So I'm going to give you some steps for understanding how to write the names of these ionic compounds. Okay, so let's see if you can see this. Yes, so there's going to be 3 steps to name these. So you can write it on this sheet or you can write it on your own paper. So naming ionic compounds. Actually, I think it's only 2 steps. All right, so the first thing is you're just going to name your metal. Remember, that's the first element. So name the metal exactly as it appears on the periodic table, okay? So if you have cesium, that is exactly how it looks like on the periodic table. And we're pretty much just looking at metals in the first 2 columns. We're not going to look at the ones in the middle. On your periodic table, they don't have charges that are given. There's a special reason for that, but we're not going to get into it. The second and final step, so there's only 2 steps, is name the nonmetal. But we're going to do something different. We're going to name the nonmetal and we're going to add the suffix. Does the suffix come before or after the name? After. So we're going to add the suffix IDE. Okay, so we're going to add an ending on the name. We're actually going to take part of the name off and then we're going to add IDE. Okay, and as you're getting used to this, you don't have to worry so much about all of that. Well, that's naming, okay? And then over here, the names are already given. So I'm going to have to go to the back side of this page so we can look at how to actually name these. Let's see. Oopsie. Well, these notes are important, but they're actually going to be used for a different day. That's my fault because I'm recording this later for my kids who are at home, and I'm not doing this in class. So my fault. Now I got to go over how to actually write the formulas out. So let's back up. All right, you've got this written down, and if not, if you're still copying, pause the video, write that. But I'm going to write some steps over here for writing the formulas. Okay, so this is going to be writing the formulas. Now, when we're writing these formulas, you want to write down the symbols. So the first thing you're going to do is write the symbols for each element. Okay, and then the second thing you're going to do, so this one is going to be 3 steps. The second thing is you're going to write the charge ignoring the plus or minus sign. That's going to be understood. But you've got to look above the column for what the charge is. So write the charges without the plus or minus sign. Okay, so without the plus or minus sign. Last thing is you're just going to take those numbers and switch them. Okay, I call it crisscrossing. Makes kind of like an X. So crisscross or switch the charges or the numbers. Okay? So, I know this looks kind of messy. Hopefully you can see that enough. And pause it if you need to copy it down. So let's apply this and let's work out the first example. Okay? So let's see. It's not going to let me scroll. Not trying to do that. All right. So let's move up. And what we're doing is we're not going to prove 0. This actually, the switching their numbers proves the 0 thing. Okay? I'll explain that in just a second. So cesium phosphide, you have to look at your periodic table and find cesium, and you have to remember the first element somewhere on the left side of the periodic table. Cesium is Cs, and then we'll look at phosphorus in a second. We need to find its charge, okay? So you're looking at the periodic table, cesium's in the first column, look all the way at the top, and there's a plus something for its charge. So what's that number? It's a +1. Remember, we leave the plus off. So that's a 1. Phosphide, all of these end in IDE. So what looks like phosphide on the right side? It's phosphorus. So phosphorus is P. And then we need its charge. So look above that. And it's a negative, okay, this is positive, this one's negative, and -3. We don't write the negative in. Now, we have to switch these charges. So I'm just going to write this one more time with my final answer. So CS is going to have the 3 and P is going to have a 1, but I'm not going to write 1s in because we don't have to do that. It's not necessarily wrong, but if you take chemistry, I'll take off if you write the 1 in. We just don't do that, okay? So that's how we do the formulas, okay? So why do we do that? If you're not really good at math, then don't pay attention for about 15 seconds, okay? And if you are good at math, this will help this to make more sense. So, cesium has a +1 charge. Phosphorus has a -3 charge. So we want these to cancel each other out, but we have 3 negatives and 1 positive. So we really need 3 positives and 3 negatives, okay? So in order to get 3 positives, we could have 3 of these ions for every one of those ions. Okay, now does that hurt your brain? Maybe. Well, that's the reason why if you switch these numbers, it always makes the right amount for the positives and the negatives to fully cancel each other out. And that's what proving 0 is. We're just not going to do that part. Okay, so that's something that some other teachers like to teach. Now, let's look at the second example. Barium chloride. By the way, I got a chemistry joke. What do you do with chemistry teachers after they die? You bury them. Get it? Get it? I can hear you like groaning right now. Yeah, but it's funny. I think you might have laughed. I don't know. So, barium, which element is that? Look in the first couple of columns. It's Ba. Okay, what's the charge? A +2. So we just write the 2. Chloride. Remember, that's going to look a little different, but chloride looks like chlorine, element 17, and that's Cl. What's the charge? A -1. Now we got to rewrite this with the numbers switched. So this is going to be Ba, the 1 isn't written, and then Cl with the 2. Okay? You don't have to box that in. I just like doing that so I know this was just my work and this is really the answer. Okay? Last thing I want to tell you as we are doing these, when you get to number 4, aluminum is not in the first 2 columns. It's actually in column number 13. So I don't want that to throw you off. So aluminum is Al. Okay? Its charge is a +3. Fluorine is an F, has a -1 charge. Okay? And so when we switch these, now sometimes you're going to have another number and there's 2 numbers to write, but in these examples so far there's only been 1. But whenever we write our final answer, Al doesn't have a number written. It's just a 1 that's understood, and then the F has a 3. Okay? And that's it for this activity.